In this video, we are going to be looking at strings and the string object. So when we have a string has some properties, and its one property is length. So we can do something like this. Constant message equals JavaScript. If we look at JavaScript, it is a string. We assign it to this constant message. If we look, it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 characters in it. So we assigned it to this variable or this constant called message. So we can call message.length, and the message.length will tell us how many characters it's in it. So, and we stored that in the result in this case, but the message.length would be equal to 10. So result 1 would be equal to 10 because that's the length of our string. We also have methods that we can use with a string. So one property and a whole bunch of methods that we can use with strings. And these are very similar to string functions that are built in to many other languages. So we have a character at function that we can say what position of a string we want to look at. So we could look at the third position of the string and it would count 0 because it starts at 0, 0, 1, 2, 3, and it would tell us what the fourth letter of the string is. Okay. We have a concat function where we can concat, and inside this function we can pass it a bunch of strings separated by commas, and it will concatenate them together, much like we've done with the concatenation plus operator in previous projects that we've done. We have an index of function that will search for a string inside of our string and tell us where it's found. And we'll see examples of these coming up. With this index of, we can also tell it, if we don't want to search the whole string, we can tell it a place to start. And we know that's an optional because it has square brackets around it. These square brackets mean this parameter is optional. We don't have to specify a start if we want to look at the entire string. We can look for a substring. We can take, so this looks for a certain substring. This one will pull a subset of our string out of the string, and we can tell it where we want to start pulling it out and how many characters we want to take out of the string. Okay. So that's a substring function. Notice it doesn't spell out the word string though. Here's another substring function. It's the full string, written out substring, and we give it a place to start. Alternatively, we can give it a start, place, and an end. So what are the difference between this substr, str, and this substring and this substring? These two are the same function. Substring, we can tell it where to start and it will go all the way to the end, or we can tell it where to start and where to end. This one, we tell it where to start and how many characters we want to pull out. Okay. We also have the option for a string to convert it to lowercase and option to convert it to uppercase. So let's look at some messages, some examples. So we have a constant that's used in all these examples down here, and that's this variable called, or this constant called message, and it just has the word JavaScript in it. So if I take this message constant and I start using its function, so I can say message dot character at 4, it's going to look for the fourth, for the character at position number 4. Okay, so remember I said earlier it's 0 numbered, so this is, the J is 0, A is 1, 2, 3, 4 is the capital S. So character at 4 technically returns the 5th character, which is the capital S. We can say message.concat, and we're concatenating on a space followed by the word rules. So it's going to take my current message, which was JavaScript, okay, concatenate on a space followed by the word rules, and the result that we get in this constant will be JavaScript space rules, JavaScript rules. The index of function say we want to find the index of A. So it's going to start searching through here till it finds an A, and that is at position 0 is the J, and A is 1. So the result we would get here is 1. However, if you remember index of, we had that optional option of using a comma and telling it where to start searching. And in this case, we said index of a lowercase a, but don't start searching until character 2. So 0, 1, 2. It's going to start looking for an A here, and the first one it finds is the A after the V, 0, 1, 2, 3. So the result of this one says there's an A at position 3. And then lastly, position of a lowercase s. We don't have a lowercase s in this string, so our result that we get back is a -1. So index of returns a -1 if it doesn't find the character it's looking for. All right, substring and substr methods that are built in. So I'm going to take my message, and remember message is JavaScript. Okay, and I'm going to pull out substring 4, 5. Okay, so 4 is the place it's going to start, and 5 is how many characters it's going to pull out. So if we look here, 0, 1, 2, 3, 4 is the S, and it said pull out 5 characters. So there's 1, 2, 3, 4, 5. So it's going to pull out the SCRIP. And you can see that's what the result is here, script. Without the T, script. If I say message substring 4, so this is the full spelled out sub with string spelled all the way out, it's going to start at character 4, which was the capital S, and go all the way to the end. So that gives us script. Okay. And in this case, we're saying substring spelled out. It's going to start at position 0 and stop at position 4. Now that is a little confusing when we see that stop at position 4, because this is 0, 1, 2, 3. So 4 is not inclusive. So when we do substring, it goes 0 up to the character before that index. So it's going to take 0, 1, 2, and 3. It is not going to include the 4 that we specify there. So 0, 1, 2, and 3. We get the Java part of JavaScript. We have 2 lowercase and 2 uppercase. So we take the word JavaScript and convert it to, we say message.toLowercase, and we end up getting JavaScript in all lowercase. If we take that same message and say to uppercase, we get all uppercase characters, JavaScript. So that comes in handy when we want to compare things, because if I compare the original JavaScript with a JavaScript that's all lowercase or a JavaScript that's all uppercase, if I compare them to see if they're equal, they will not be equal because case matters. However, if we want to compare 2 objects, string objects, and ignore their case, I could take result 6a, which was this one, lowercase JavaScript, test to see if it's equal to result 6b, which is this JavaScript, but since I converted them both to lowercase, it's going to say yes, they're equal because it's comparing the lowercase version. So converting both things you want to compare to lowercase or converting them both to uppercase are great ways to see if a string is the same as another string while ignoring the case completely. Oh, there's more methods of the string object. We can also check to see if a string starts with a certain other string. And again, we have the option of telling it to start looking at a different spot within the string. We can check to see if a string ends with a certain other string, or whether a certain string is included inside another string. We also have 3 trim functions, which we can trim the beginning. So trim by default trims off spaces So we can trim off spaces from the start of a string, trim off spaces from the end of a string, or if we just say trim, it trims the start and end of the string. Okay. We also have the ability to pad a string. So pad basically says if the string is less than this length, so if I have a string that is 5 characters, I can tell to pad it to 10, and it will add 5 spaces or whatever other character I specify to the front. Same thing on the end. Hey, pad the end till this is at least 10 characters long. Okay. And I have the option of taking a string and repeating it a certain number of times. So let's look at some examples here. So these examples all use these two constants. jQuery is the str, the constant str, and we also have len, which is the length of jQuery, which is 0, 1, which is 1, 2, 3, 4, 5, 6 characters. Okay, so here's an example of the starts with. If we take our string and call it starts with, and we look to see if it starts with a lowercase j, we would get true. If I tell it to see if it starts with j, but start at the second character, the second index, which would be the u, we'd find out that it's false because it starts there with a u, not with a j. We can check to see if it ends with an ry. It does end with an ry, so the result is true. We can check to see if it ends with an ry, but start here at position 2, position 2, and it still ends with an ry. Actually, no, the 2 here is telling it where to stop looking, not where to start. So it never gets down here to the ry, it stops at the u, so I get false. There's no ry going up to position 2. Does our string include the letters Q, U, E? Obviously, jQuery does have QUE right in the middle of it, so dot includes QUE would return true. Dot includes QUE starting at position 2, 0, 1, 2, starts at the U, so it's ignoring the Q, so that returns false. Here's our padding examples. Okay, we're going to pad the start of our string with its length plus 3, and we end up getting spaces padded on the front. Okay, we're going to get 3 spaces padded on the front. We're going to take the length of our string plus 3, and we're going to pad on dots at the end, and we get the length of our string plus the 3 dots. So this one, pad start, pads the front, and since we didn't specify anything, it padded spaces. This one pads the end, and we did specify what to pad with in quotation marks, the dot, so it added 3 dots at the end. Here's our trim examples. String pad start length plus 3. Now notice they combine the 2 that they did up here. Pad the start with the length plus 3, then pad the end with the length plus 6, and we end up getting 3 spaces in front of jQuery and 3 spaces at the end. So string 2 has extra spaces in front and back. If we do string 2.trim start, it removes the spaces at the front. If we do string 2.trim end, it removes the spaces at the end. And if we just do string 2.trim, it removes the spaces at the front and the back. So all of these functions can be useful at different times. Trimming is one of the most valuable ones when you're working with forms, because often people type in extra spaces at the beginning or end of things, and we can trim those spaces off. And I think we've seen examples like that already in some of our applications that we've written or applications that we've examined. Here's the repeat method. We got hey with a space in it. It's a string. So because that is a string, even though this is a literal, it's not a variable or a constant, we can tell it to repeat 3 times and store that in the result, and we get hey, hey, hey. All right, a string method that creates an array. So we can take a string and we can split it up into parts. So we have a dot split method, and this is also one of those string methods that's in a lot of other languages as well. Anytime you take a string and you split it up, you can specify usually a separator, and you can say what you want to separate on. So I could separate on a space. So if I have a long sentence, I could split my sentence into words by telling it to split on the space. Let's look at some examples. We have some constants we're going to be using in these examples. We have full name, which is Grace M. Hopper, and we have a date, which is 7-4-2021. So if we take this full name, Grace M. Hopper, and we say full name dot split, and in here we tell it we want to split on the space, we end up with an array called words that contains Grace as a string, M as a string, and Hopper as a string. Notice the spaces that were in here don't get included, and it splits these into 3 separate strings stored in this array called words. Okay, and there's actually technically a name for this, and these are called tokens. Okay, so we split this string into tokens based on the character space in this case. Here we're taking words, since it's an array. Words.length tells us how many words we got out, and we're storing that in the length. And then last name equals the words sub length minus 1. So length minus 1 would be 2. So this is an array. We're calling up the last word by index. Length minus 1 would be 2. So 0, 1, 2, we get the last name Hopper. So we were able to split this full name on the spaces and then pull the last name out by looking at the length minus 1. In this example down here, we're going to use the date 7-4-21. And since that date is stored as a string, 7-4-21, we can call date.split, and we can split it on the dash, and we end up with an array of strings with a 7, a 4, and a 2021. So if we look at this array, date part sub 0, we get 7, so we know the month is 7, so that would be July, right? Date parts 2, 0, 1, 2 would give us the year. So we were able to split a date stored as a string and pull out its month and its year, and if we wanted to, we could pull out the day if we wanted. If date part sub 1 would give us the day. So we broke that string up into its constituent parts. What if we took the full name back here, Grace M. Hopper, and said full name dot split, and we used an empty string? There's no space in there, that's just an empty string. Well, that would split it on every single character in the string, and we would end up with an array of all the characters that were in the first name. What if we wanted to pull out just one element from a string? So take Grace M. Hopper, we'll split it up, looking at the spaces, but we're only going to pull out the first one. And that just pulls out the first name, Grace. If we say first name dot length, it tells us that there's only one in there because that's what we told it to get. We told it to get the first token out of that split up string. I think I told you that when we split these up, each individual item is called a token. The actual process of splitting a string up into pieces is called tokenization. I don't think the book uses it, but other languages will. So that's the technical name for this, splitting a string up into substrings or individual characters even. We're creating tokens, so the process is called tokenization. And then they're saying hello. So we could pull the first name out. In this case, we got the first name. Hello, Grace is what it would end up printing, because it's going to take the first name and use the first name that we did right here. What happens if the string doesn't have the separator? So, hey, take that date that we were working with and split it on the slashes, but we don't have any forward slashes. Okay, remember the date had dashes in it. So the length is 1, date parts length equals 1, it didn't split it. What if we tried to split a string that contains the separator at the beginning or end? So for instance, if we had a path variable or path constant directory with a slash in the front and a slash at the end, and we tell it to split on the slash, okay, what is it going to split it to? Well, it's still going to split it. It will remove the delimiter character, and that is what that's called when we were using space. Space was the delimiter. When we used the dash was the delimiter. This case, we're using this forward slash as the delimiter. So what does it do if there's one right at the beginning or right at the end? Okay. It creates an empty string first. It has the word directory and then another empty string at the end. So it still splits it into 3 parts based on these 2 delimiters that are there. But the first one and the last one in this case end up being empty strings. So strings have lots and lots of methods, lots and lots of functions built in. Because we spend a lot of time processing strings, it is nice that JavaScript includes so many ways to process them.